In an X-ray tube, it is observed that the intensity of X-rays increases when potential difference across the filament is increased. Explain this observation. And before we answer this question, it is good to know that we have a potential difference between the filament, that is across the filament, that is one, and we have a potential difference between or across the anode and the cathode. So these two, when you ask about the two, they are very different. Why? Because this potential difference across the filament, we know that the use of filament is to heat the cathode in order to produce electrons, and the need for the potential difference across the anode and the cathode will be for the acceleration of the electrons. Therefore, the potential difference across the filament will increase the heating effect, because we know filament is the one that is used to heat the cathode to produce electrons. So in the filament, when the potential difference is increased, more heating effects will occur, and therefore the number of electrons will be more. And it is the number of electrons that determines the intensity. Remember, the intensity is the quantity of electrons. So intensity of X-rays is determined by the number of electrons, and this is caused by high heating effect on the filament and thus the cathode. But now when we come to the potential difference between the anode and the cathode, this is what we call the accelerating voltage. So this will have the effect on the speed of electrons, and the speed of the electrons is what determines the strength of the X-rays. Therefore, because our question is asking about the intensity of X-rays when potential difference across filament is increased, the answer will be an increase in potential difference, PD, increases the heating effect, as we have said. This produces more electrons by thermionic emission. As a result, more intense X-rays are produced. So in other words, more electrons, more intensity. High accelerating voltage, high strength of X-rays.